So now this is first time we use the R, but I will not do any complicated coding. So here we're gonna install a package. The name will be the Uldrich. So actually this Uldrich is the textbook that I'm referring, the introductory econometrics, because this textbook is quite widely used. That's why there is an R package. So you don't have to download the data file for this textbook. All the data file this textbook use, you can simply download. Okay, so successfully unpacked, and then we got it. And then which one should I use? Then I will call data or crime 1. So we will use a crime 1, and the package equals Uldrich. And as you can see, I am using package here, and then I'm call the data file is crime 1, and then you can see that this is the crime 1, and you can see the bunch of data here. Actually, this is the what we call the data frame, and then we can do the regression. So when we take a look at it, what was the NARR 86 is arrest at 86. But if you type in, then as you can see, the R cannot find out what is this one. So you have to call, because my data frame is a crime 1, and then apply the $, and then you can say the NA number of arrests. You can calculate the mean. You can simply do the summary. Alright, so you can see the mean, maximum is 12, and so on. So I wanna create the linear regression. Then you can name it. This is the number of arrests. So arrest. You can name it anything. And as R uses this arrow. Actually, the inequality and minus is actually the arrow. You are calculating this right hand side, and then put that result into the variable arrest. So LM is a linear model. This is simply linear model, and then you can specify what is the independent variable and what is the dependent variable. So dependent variable first. So y. So the form is a y tilde, and then you can write the x1 plus x2 plus this form. Okay, this is the form. Oh yeah, of course we don't have a x1, x2, and y. So I will write down is NARR 86 tilde will be the I will randomly choose variable P, C, and V. So crime $1, this one, plus crime $1. So you have to specify the data frame name, and then in the data frame name what column you're gonna use, plus crime $1 this is kind of tedious. Okay, I will tell you what we can do. It's a p time something like that. Then I'm creating the regression linear model. So number of arrest 86 will be my dependent variable, and instead of equal it will be tilde, and then PC and V, I don't know what is PC and V, and then average is sentence, and then prison time, and then you can enter. Yeah, of course I didn't specify the frame name here, right? That's why if you press the upper arrow, then you can call the last comment crime $1, then it should be working. Now we have a arrest. That's the result of the regression, and then you can see the summary of the arrest. Then you can see all the regression result. So formula will be the crime number of arrest equals something something something. So you can have the intercept. This is a beta 0, and this is the coefficient for the PC and V, right? And then this is coefficient, and then of course you can see the p value, right? This is a smaller than almost 0, and this is also pretty small, and this is smaller than 0.05, so everything is significant. And then yeah, and then this p value is about the F test, okay, F statistics. So here F statistics is the null hypothesis will be here the null hypothesis. Here the null hypothesis, it will be beta 1 equals beta 2 equals beta 3 equals 0. So all of them doesn't have an effect. That's the F statistics for the H0. Now here T statistics is a H0 for the T, it will be different because this is a 1 at a time. So here the T, first T equals beta 0 is equal 1. And second one, null hypothesis is the beta 1 equals 0. And beta 2 equals 0 and so on. So that's why the F statistics and the T statistics, null hypotheses are different. However, in previous session, the simple regression, since we have only, in simple regression, we had only one variable. That's why F statistics and then T statistics are the same. But here in multiple regression, F statistics and then T statistics are different because null hypothesis is different. Okay, so this is how it's very simple. You just use a function lm and then you write the formula without coefficient, and you specify which one is which one. But yeah, I will tell you how you don't have to write the crime $1, crime $1, and so on. So one way you can do is attach crime 1. Attach means we will consider only crime 1 data frame. So once you do that, you can do the same thing, but you can erase all this crime thing. You can just type in only the column name, right? You don't have to type the crime 1 here, because since I attached this data frame, so the R will consider, okay, PCNB means it's a PCNB inside of the crime 1. So if I type in that this is arrest 2, because it's a different name, then you will have RS2. So if you type summary of the RS2, so you can have exactly the same result. Okay. So partialing out, we can find this estimate, but if I'm looking at this PCMB, another way to get this minus 0.155586 is this way. I'm doing regression. Okay, so partialing out, I'm doing regression, but now I'm doing PCNV with other things, average sentence plus P times 86, right? And then I can do the regression here. So if I do the regression for one specific variable against all other variable, and then if you want to calculate the get a residual, you can usually use a simple the residual. So I will not type in here. So yeah, let's do the regression again. Now it's RS3 linear model, and then number of RS 86. Yeah, we will do this, and then instead of the PCMB, we can do the residue. So this is a function for the residual. So RESID is a residual of PO, then you can collect the only residual part of this regression. So regression of the my specific factor against all other factors, and using that one, do you remember the partialing out I mentioned was you calculate, you do the regression with so x1 equals like it should not be better because that's should not be gamma 0 plus gamma 1 x2, right? And then plus u, and then you take this u and do the regression again, y equals alpha 0 plus alpha 1 u. Then this alpha 1 will be same as the original regression, beta 0 plus beta 1 x1 plus beta 2 x2 plus u. This alpha will be same as its beta 1 because this is about this u contains x1, purely x1 without the part of x1 that can be explained by x2. So let's see, we have the same value. This number is our beta 1, right? So our beta 1 equals minus 0.155586. So now we calculated this regression. This regression is this regression, right? And then we take a residual. So this is the function we use, is residual of this regression. Here I name it PO, so it's a PO. And then I'm using this residual U, and then find the Y again. Do the regression. And then if you find the summary of the RS3, right? Then what you can see here is right? This is exactly same as the previous number. So this is what we call is the partialing out.